Welcome back to 16.2 arc length and radian measure. We're going to begin on page 30. If at any point I'm going too quickly, please pause. But here we go. So here it says applying the formula for arc length. So let's go over what that is. Arc length is denoted by the letter S. And it measures the part of the arc that you see here of the circle. So from, like, let's say from P to Q, if I wanted to know from that point to that point, that measures that length. It's like the slice of your pie, of a pie. Yeah. Anyways, notice that our angle measure will be M for measure. And that'll go right there. You're like, but the M's here. Either one, they're the same. So whatever number that's going to be, whether it's 20 degrees, 50 degrees, that's going to go right there. And it's noted by the degree sign. So if you're like, what degree sign? They usually looks like a little 0 in the upper right-hand corner. Okay, it's not an exponent, just so you know. And then we're going to multiply that by, this should look familiar. It's like, looks like circumference, 2 pi r, otherwise known as our radius. So I'm going to write that in. Radius. All right, so let's continue. So we're going to use this in the next one. So here we have finding the measure of PQ. So let's take a moment, write that in. And just to help you out, I'm going to color code some stuff. So remember, our angle's going to go here. And our radius will go here. So take a moment right now, pause, and fill in the blanks. And unpause. Hopefully you put the numbers in these places. You're like, now what? So, what we're going to do is we're going to keep that 360, which is on the denominator side, and we're going to multiply out all the numbers highlighted in purple. So, let's multiply the number parts of our problem, 62 and 9. Go ahead and take a moment, pause, and do that now. And unpause, you should have gotten... By the way, notice we're still going to keep that pi symbol. He's still there. But if you multiplied 60 times 2 times 9, you should have gotten 1080. All right, let's go ahead and divide out 1080 divided by 360. Go ahead and work that out. And hopefully you divided that out because pi is still there and 1080 divided by 360 is 3 pi. If you really wanted to put it in terms of not pi, like a decimal, you want to know what that decimal value is, you can always work that out by saying 3 times 3.14 and working that out. I won't do that here on screen, but if you're like dying to know what that is, like you want to know what this is, take a moment, calculate that out. Moving on though. So here we have AB. So again, right now, I'm going to color code some stuff for you. Label. But go ahead and put where you think these numbers should go. And unpause. You should have put the numbers here and here. All right. Whoa, my degree is super off. Yeah, that should go over there. We'll continue. All right. So again, we're going to simplify this out. So 360 will stay as my denominator. Let's go ahead and multiply the numbers in purple. 125 times 2 times 6. Pause and do that now. Unpause, that would be about, so let's multiply the number parts only. That would be, drumroll please, 1500, 1500, wow. Let's go ahead and take a moment and divide 1500 by 360. Take a moment and do that now. And unpause. Hopefully you put 4.16. Like I said, if you really want to know what that is as a decimal value, you can always write 4.16 times 3.14. Coincidentally, pi, that symbol we keep using, an estimate for that would be 3.14, though if you put this in the calculator, if you Google what is pi, not like the food pi, but the actual mathematical term pi, the numbers kind of go on forever. But this is a good kind of estimate to use. All right, let's continue. So there is a problem here. It says a minute hand of a clock is 8 inches long. Okay, so we're going to talk about a clock, like the ones that, you know, tell time. To the nearest tenth of an inch, how far does the tip of a minute hand travel as the time progresses from 12 to 12:45? So we're going to highlight that important information, as you should be doing so as well, or underlining, either one. And just to kind of give you an idea, this is about 45 minutes. Yes, I googled this image as to what 45 minutes looked like. So essentially here, from here to here, that's 15, 30, 45. By the way, each one of these kind of quarter pieces is about, yes, 15 minutes, but in degrees, this would be about 9, oh, sorry. Let's first measure, what is our radius? Our radius is 8 inches. For degrees, though, because we need to know, because this is not a degree, we need to actually have a degree to calculate some stuff out. So if this right here from 12 o'clock to 12:15, that would be about 90 degrees. If I continually add 90, so that I have it from 12 to 12:30, what would that be? 180. Let's add one more 90. What would that be? 180 plus 90. 270. So now we have our angle measure. Now we can place our angle and our radius. So is 270 or 8? Which place should they go? 270 should go in the degree and 8 should go for radius. So we'll do this yet again. So let's go ahead and multiply 270 times 2 times 8. Let's multiply the number parts only. So that would be 4,320. Wow, that's a really big number. Let's go ahead and work out when we divide 4,320 divided by 360. What would that be? Notice how I still keep the pi. And unpause. Hopefully you calculated that out to be 12 pi. Now since they want it in terms the nearest 10th inch, we're going to take some time and multiply 12 times, let's pretend you didn't see that, 12 times 3.14. And also correct me if you see something incorrect, please let me know. You're watching the videos, come to the center, let me know, or you can make a comment and let me know if this is indeed a correct calculation of 12 times 3.14. Is it? Or is it not? I'll be waiting for your response. All right, let's move on. Oh, and notice how they did want us to the nearest tenth of an inch. So that's this decimal place here. So 37.69. If I rounded that, would it be closer to 37.6 and it stays that, or 37.7? That'd be about 37.7 inches. Okay. All right, so one of the other examples they asked us to do is explain 3, converting radian measure. So on here it says, what steps do you take to convert an angle measure to a radian measure? So let's say I have a degree of 60 degrees. What I'm going to do first is I'm going to multiply the degree of 60 by pi over 180. All right. The next thing I'm going to do is you'll notice like, oh, I'm just multiplying 60 times pi is just 60 pi. I'm just putting the number and the symbol together. So how do I kind of reduce that? Well, notice how I'm just dividing by 60 for both. So 60 divided by 60 is 1, and 180 divided by 60 is 3. So essentially I'm just reducing. Some students like, how did you know it was going to be 60? So let's say if I wanted to reduce the long way, let's say I said, oh, I'm going to cut it in half. That would be 30 and 90. Let's say I want to cut it in half again. That would be, let's see, 15 and 45. I can't cut it in half again, but I could divide by 5. So that'd be 3 and, what would that be? 9, and then, oh, I could do one more. 3, 3, that'd be 1 over 3. Hey, I still end up the same way. It's just, I take a little bit longer. That's fine. And if you have questions on how would I reduce, come into the center. Let's practice that out. Let's make sure you're really solid in doing that, because we're going to be doing that a couple of times in the homework and in the packet itself. So let's go ahead and convert some angles. So 90 times pi over 180. Let's go ahead and work that out. So what's 90 times pi? 90 pi. Essentially you can reduce, and here's a hint, you can kind of reduce by 90. So what would be 90 divided by 90 and 180 divided by 90? Let's pause and work that out. Calculate that out. And unpause, the top number would be 1, bottom number would be 2. So number 8, 45 degrees is my angle measure. Multiply that by pi over 180. Equals, what would go in the empty space? 45. So again, we can reduce the long way, or we could divide by 45. And what would be my top and bottom for our fraction? 1 and 4. And we're at checkpoint for number 1. Go ahead right now. I'm going to highlight some stuff for you and draw some stuff out and work that out. And unpause. Hopefully you work that out on your own. We're going to check it just to make sure that the numbers are correct and in the correct place. We're going to work that out. Hopefully you multiplied your numbers and got that. You divided everything out and you got 2 pi. You could also, like I said, multiply 2 times 3.14. So if you left it in terms of pi, it's not that it's wrong, but notice how they do want us in the tenths to the nearest tenths place. So that would be about 6.28, which if I round to the nearest tenths place, that would be 6.3. All right, we're going to convert 12 degrees to our radian measure. So 12 times pi over 180. Take a moment, work this out. And unpause, that would be 12 pi. If I reduce this out, that would be what? That would be 1 over 15. So if you need help on any of the homework, which is what follows, here's some support on what you might need to do, though I won't work these out for you. But feel free to pause if any of this is helpful for you to work out numbers 13, 14, 15, and if you need support on 21 or 22. All right, we'll see you here on the next video.